So for this part, we're going to recap on three things. Number one, how to calculate the gradient of the straight line. Where do you get the y-intercept of the straight line? And using this tool, how can we calculate the equation or write the equation for the straight line? Alright, so number one, gradient. Now, gradient refers to like the slope. So the idea of a gradient represents like how sloping the particular line is. Okay, so which means like if it's very steep, it will look like that. If it's very gentle, it will look like that, right? Okay, so that's the idea. So to calculate gradient, okay, we are going to calculate the rise over run. For this particular straight line. Right, so how do we calculate the rise? Number one, I would like to get two coordinates from the graph. So let's see, the graph is here. So one of the coordinate would be 2. The other coordinate would be 6. I mean, the y coordinate would be 6 and the x coordinate would be 2. So let's see. Okay, so let's get the other coordinate here. Would be 1 and 3. Alright, now let's draw. So for some students, I tell them to draw this gradient triangle, which is, you can see this is the rise and this is the run. Okay, so this will be the rise. So the rise is from, so we'll get the difference in the y coordinate. So the rise would be 6 minus 3. And the run will be the difference in the x coordinate, which is 2 minus 1. Alright, so, and you can press your calculators and you realize that the gradient is 3. Okay, so it tells you how steep the slope is. So that means it's 3 units over 1 unit. So 6 minus 3 over 2 minus 1. So that's your gradient. Okay, so this is for part A. Now part B, the y-intercept of the graph tells you where it cuts on the y-axis. So for example, just like a quick sketch. So if I have a y-axis here and an x-axis here and a straight line. Okay, so this straight line cuts the y-axis at this particular point. And this y value would be your y-intercept. Okay, so let's connect this to the graph that we're supposed to look at. And what will be the y-intercept for this graph? So this straight line cuts the y-axis at this point here. Alright, so which means that the y-intercept is equals to 0. Now, using this idea, we know that the equation of a straight line, so the equation of a straight line has a general form of y equals to mx plus c. So the m stands for gradient, and the c stands for y-intercept. So to come up with the equation of the straight line, we simply have to substitute the value of m and c. So because this line has a unique gradient and a y-intercept, so therefore when we substitute in, the gradient is 3 and the y-intercept is 0. So therefore this equation, so the equation of the straight line here, is equals to y equals to 3x. So which means that whenever you substitute a value, for example, when x is equals to 1, or, yep, so when I substitute x equals to 1, y is equals to 3, and I can check, right, so it's almost like you input a 1 and you get an output of 3, something like that. Okay, so we check that this is good and this is correct. Alright, let's look at the second graph that we have over here. Now you can see that the line is downward sloping. Alright, so that would give us a negative gradient. Well, don't take my word for it, we're going to calculate it. So for part A, let's calculate the gradient again. So the gradient, we still use the same concept, whether it's downward sloping or upward sloping graph. So we call it like rise over run, but instead I kind of call it like the drop. Okay, drop over run, because it's kind of like dropping, right? So let's say if I have a coordinate here, okay, I'm going to choose two coordinates here. This coordinate here is 0, 2. And this coordinate here would be 4, 0. So reading from the x-axis first and then the y-axis, right? And you can see that from this point to that point here, from the first point to the second point, it dropped, right? So we will draw the gradient triangle from here. So it's a drop, and this is the run. Okay, so let me look at this again. So this is like a drop, and this is a run. Okay. So how much did it drop? Well, the y-axis, there's a 2 minus 0. So the drop is 2 minus 0, and the run is from here to here, which means that that would be 0 minus 4. So I'm taking 0 minus 4. So you notice that it's going to be a negative number. So you have 2 divided by negative 4, which means that the gradient is negative half. Now don't worry about the negative number, because it tells you that it's downward sloping. That means it's like that. Alright, so it's downward sloping. Alright, next we're going to look at the y-intercept. So part B, so that means when this is downward sloping graph, alright, so we have a y-axis here, we have the x-axis here. So when it downward slopes, the line cuts the y-axis at this point, and so this gives you the y-intercept. Right? Okay, so let's apply this to this particular graph over here so that we know what the y-intercept is, or maybe you are already seeing it right now. So the y-intercept is 2. Okay, now using the y-intercept and the gradient, we're now able to get the equation of the straight line. So remember, the general equation for the straight line looks like that. Y equals to mx plus c. And so when you substitute the gradient and the y-intercept, you would be able to get the values, the entire equation of the straight line. So what is the gradient? So the gradient is minus half. Y-intercept is 2. And therefore, the equation of this straight line will be y equals to minus half x plus 2. So this will be the equation of the straight line. So remember, the negative sign in front of the gradient would tell you that this is a downward sloping graph. so this part of the graph tells you how to plot a linear graph. Normally, you might have to plot 5 points. So in this case, you just have to have 3 points. In fact, to draw a straight line, right? Imagine if you were to have to draw a straight line, basically you just need 2 points and connect the 2 points and you will have a straight line, correct? So one more point is actually an extra. So plotting the graph, you need the coordinates. So how do we get the coordinates? So I can choose when x equals to -1, 0 or 1, I need to get the value of y. Let me just show you the process so it'll be easier for you to understand. Now the equation that we need to plot is right over here, alright? Okay, now, so this is the equation that we're going to put in the input and see what's the output. So when the input is x equals to -1, y is equals to, so I'm going to input the x value. So here is -2, -1, so I'm doing it really slowly, just so you need it. Okay, so therefore the first coordinate is -1, -3. So when x is equals to 0, so I'm going to input another x. So what is my output? So I'm going to put in my x and I get y equals to -1. So that would be my next coordinate. So actually 2 coordinates is enough, but we're going to just do one more. So when x is equals to 1, I'm going to input x equals to 1 into the equation. And alright, so 2 times 1, 2 minus 1, that would give me 1. So that would be this. And the next step is to mark the coordinates on the graph. Okay, so -1, -3. So I have one more here that I can use. Or I should be writing it the other way here. Okay. Okay, so I have -1, -3, and 0, -1, so 0, -1. Okay, and finally 1, 1. Okay. Just try to snap it to grid. Yep. And now I can join the points and draw the straight line. Okay, let me just make some adjustments here. Just make sure that your points should really be touching the graph. Okay, yep. So then what I always ask students to do is remember to label the graph that you draw, because sometimes certain questions you might need to draw more than one graph, and make sure that it is very clear. Alright, so that's how you plot a graph, a straight line graph, or generally just how you plot a graph.